Good evening friends, Pradeep Kumar here. So today's topic will be on AODV protocol. So AODV means Adhoc on demand distance vector routing protocol. So this is AODV protocol. So what this AODV protocol will do is whenever a route is being computed, the route will be computed during runtime. So every time there will not be a routing table will be maintained, and the routing table entry will be keep on dynamically changing as and when the nodes are nearby. So for example, if a node want to send a packet to the destination node, in between there could be so many forwarding nodes or intermediate nodes will be there. So the intermediate nodes will always never be the same route for the packet number 1 and packet number 2. It might be different. Suppose if the nodes are mobile, suppose if the nodes are moving here and there, so as per the mobility the nodes will move away from the source node. So during the second packet it might be sending from some other intermediate nearby node. So this kind of routing is called as AODV protocol. This is mainly in AODV. So AODV is very optimal protocol that optimizes energy. Only thing is for computing the routes during runtime it takes some slight overhead. In other cases it will be very good enough. There is another protocol called the DSR routing protocol, dynamic source routing. It is almost similar to AODV protocol, but only one difference is DSR initially it has a cache memory. So in the cache memory it stores all the path from source to destination. So that means suppose there are 10 paths available, 10 path from source to destination via 10 routes available. All the 10 path or 10 route will be stored in the cache. So we have a cache memory available for a DSR protocol. So if one of the route fails, immediately through the cache it goes to the other route and then it transfers the packet. So that it is like initial level it first do all the indexing, then it select the path according to their failure of the routes. But in AODV the link failure or a path failure is the greatest disadvantage here. So whenever the path is failed or the nearby node is very far away, so the packet might be getting lost. So this protocol we are going to see how it is implemented in NS2. Okay, so I am not going to the complete coding part of it, but I will tell you how the skeleton works. Okay, so the location of the codes, the location of the source code for AODV is in the folder, so ns-2.35 /AODV. in this folder we have all the source codes available. So let me open a file. So I just ns only 2.35, then ns-2.35, then I have AODV. So you can see AODV here, AODV. Now here we have so many things available. So you can see corresponding to each .cc file you will get a .o file. It is not on the header file, it's only the cc file. So AODV logs, so all the tracing data will be, their codes will be in the .cc file. A routing queue, so how the routing queue is being maintained, so that kind of source code will be there here. Routing table, we have a .cc table here, so the routing table entries how it will be made will be available here. And we have the main algorithm aodv.header file and the source file and .cc file. So first thing is we will open these two. So what I do in this lecture is, this is lecture number 11 I think. So in this lecture number 11 I will be dealing with for example, just let me write it down. So lecture 11 AODV part 1 I will put. So the AODV alone we can do so many things, so I will do so many things with the AODV. So many things with the AODV. So I will have so many paths. We will see attack codes, we will see energy runtime information processing, we will see some packet forwarding thing. So in this part we will see just packet forwarding, how to modify the existing AODV protocol as per my convenience. Okay, a simple model I will just tell you. So this is my two files, aodv.header file and aodv.cc file. My advice is, anytime my suggestion, not advice, suggestion is always try to understand the header file first. in the first place try to understand the header file first, later you can move on to source file, preferably in this case here .cc files. Okay, so I will just go through aodv.header file first and then aodv.cc file next. So let me explain this. Okay, so now in the header file, first I go to the header file. So this is my header file. So there are some copyright information and we have header files that includes here. Then there are some macros. Now we have come to the source code here. First thing is class aodv. A class has been started, and here we have route timeout is totally 100 seconds. So the value is given as 10, totally 100 seconds. Active route timeout is 50 seconds. Route life is 5 seconds. Broadcast ID save is for 3 seconds. So these 5 seconds, 3 seconds, 100 seconds, 50 seconds, they are all very bigger timing, because most of the routing will be happening in milliseconds, but they have a timeout interval of up to 100 seconds. Then RREQ retries. So that is what RREQ is. Receive request. So for what happens is, whenever a node enters into the AODV in a wireless network, it sends a hello message to all the nodes, the nearby nodes, the hello message. So after the hello message, the nodes will be hello message will be a broadcast message. So the nodes who are all nearby, they will be receiving it and they will be replying back. So that is a broadcast ID. So we can use the broadcast. Next thing is route request. So whenever a node wanted to send, a source node want to send a packet to the nearest node, it will send a route request, RREQ it will send. So you can see this here, how many retries it can give. Totally 3 times it can able to send retries. So after third time it will be failed. So that means if the nearby node is there, so as a source node, I cannot think that all the intermediate nodes will be accepting my packets for forwarding to the next node. Some nodes they deny. So I will give a route request as a source node. I will be giving a route request to the nearby node saying that RREQ packet. Suppose if the receiving node is ready to accept your packet, they will be sending you back the route response, RREP they will be sending. So then only the packet exchange will be happening. In that case, suppose how many times a source node can able to try the neighbor node for RREQ. So it will be trying for 3 times. Timeout second is totally 10 seconds. So time to various used for expanding ring search. So time to leave start 5, the threshold is 7 and increment. So these are all some parameters. Now we will come to the code directly. We have some timer class, broadcast timer. So broadcast timer, these are all the NS2 core libraries. They are all from NS2 core. So there are so many timers are involved here. So broadcast timer is, so once I send a hello packet, I will start a broadcast timer, because how long the packet will be there, how long the node has to wait. There should be a timer running in the backend. So the timer will be here, and in this we have the event and the agent. Then hello timer. So this is for hello messages, and this is for neighbor timer. So we have these timers: neighbor timer, hello timer, and broadcast timer, and route cache timer, routing cache timer. So because for a corresponding route, for the particular route, it will be maintaining a local cache. So how long the local has to be maintained, and local repair timer. Suppose if the route fails, and how long it takes to repair. So further we have a timer. So these are the timer classes. There are totally 5 timers are being used. Next thing is broadcast ID. So broadcast ID is a separate class which inherits or which makes a front class, AODV class as a front class. So as you recall the C++ topic on front class. Okay, so list head means, so this is one of a list head means this is a broadcast ID. So how many packets are being broadcast? So list head means it is like a linked list. So in the linked list, what is a head node contains? So it's a broadcast cache ID and the broadcast ID. So these 2 things it has. Okay, so now the things final, these initial things. Okay, now we'll come to the routing agent. So this is what the main thing in AODV. Now we can see class AODV public agent. Please remember, already in the beginning there's a class AODV is used with only a semicolon. Here you can see this here only a semicolon. This is to indicate that this same class is being used somewhere in the class here, like AODV star agent, like that. So only for this reason it is defined there. Now only it is being used here in the agent. So aodv is also one of the agent. So this agent will be available in agent.header file. You can see in the beginning it is included there. Now make some friends first. So now you can see there are 5 timers, and along with the table routing table entry, they are all friend classes. Friend classes means like a friend. So if I allow my friend for some of my work, my friend can able to do, I will allow him to do my work or access my data. So this friend class will have this many access. So broadcast timer, hello timer, neighbor timer, root cache timer, local timer, and aodv routing entry. So this will be my friend classes. Next we have public members, protected members, and private members. So we have 3 things: public, private, protected. So in the public, first thing is we have a constructor. The constructor, we have a address type, so a network simulator address type ID, and receive packet P handler, receiving the packet. These are all the public. So public, because why receiving is public, in a public function is any node can able to send my packet. Even if I want to accept a receive packet or a hello message from other nodes, I should be given a public access. So that's what. Protected in the sense that it is protected only to the subclasses. These classes will be available. So now we can see command. Already you can recall my earlier section class on what is this command function will do, what is argument count and argument vector will do. So this you can able to understand from lecture number 10, creating a new agent. You can see that you can easily understand how to create a new agent. The same method has been used here in aodv also, but aodv protocol and all will be there. Okay. So now we come to the main part, routing table management. So in the main algorithm we have routing table management. Please remember, I am still looking at the header file. I have not gone into the .cc file. So in the header file, when you understand what is your purpose of your research, where you want to do your research, if once you know the header file, then you can go to the source file for understanding the algorithm. Usually students and researchers, what usually they do is, it's a caution. Usually what they do is, I should know where my work is residing. For example, in aodv, should I work on routing table, or so I will use like this way, routing table, or energy management, or quality of service, or link failure, or logs or tracing, so or neighbor management. Attacks like black hole, gray hole, etc. Security. So in which area I would want to work on, so I should know about that. So first thing is, you please understand how these things have been defined in the header files. So prefer to stay at the header files first, then you go for C file. So still we are in the header file. So now we have routing table management. Now in the routing table management we have some of the functions: resolving, update, routing table. So you can see the parameter is packet P. So resolving means how to resolve it. So we, during black hole attack, I'll handle this function. So during routing table management itself, how a node try to drop a packet, so that will attack in a black hole attack we will show you. And update means how the routing table gets updated based on the routing table entry. So now we can remember that this class is a friend class, as defined here. This is a friend class. So for this class we have an object and integer data type in 32 bits sequence number, and any metric, and next hop, and expire time. You can see that next hop means the routing table update, who will be my next hop, and what is address type, and the expire time, how long it will be maintaining, and routing table down, if at all anything is there, if it down, what happens. Then local routing table repair. So how I repair it based on these two parameters, routing table entry and the packet. Then link layer failed. So if the routing table link failed based on a packet, if a packet doesn't reach a particular destination, maybe in between some route would have been failed. And handle link failure, how to handle the link failure based on this address of the node. So that is what this value. And in the protected mode I have a RT purge, routing table purging. Purging means, for example, having multiple routing entry for the same route. Suppose, for example, in packet number 1, packet number 2, the nodes are not moving, the same route is being followed. So in this function, what happens is multiple routes for the same route will be maintained. Purging means making into a merging every duplicate data into a common data. So that's what purging. So usually it will do the purging. Next thing is NQ and DQ. NQ means putting into the queue, and DQ means deleting from the queue. So that means any node which is there in the routing table entry, this packet will be put into the queue and packet will be dequeued. So the packet which is going to the routing table, how I will be NQ and DQ the packets based on these things. So routing table management, if I want to do my research on routing table management, I should concentrate only on these functions. Now in this function, let me go here. For example, resolving. I'll just copy this, go here, just see, and this is the resolve function. So structure header common and a routing table entry, and if this header, if the common header transmit failure equal to failed callback, then how this function is. If the route is up, forward the packet. If I am the source of the packet, then do a route request. A local repair is in progress, buffer the packet. I am trying to forward a packet for someone else to which I don't have a route. So like this, you can able to understand the complete route, I mean your complete algorithm. Okay, let me come to this here again. Next thing is neighbor management. Neighbor insert, neighbor lookup, neighbor delete, neighbor purge. So inserting the neighbor, everything is a data structure. So you can recall the linked list, tag, queue, all these things you can able to recall. How do I add a neighbor in between? How do I add a neighbor at the last of the stack? How do I add the neighbor in the front of the queue? So these things you can able to find it out. So lookup means who is the neighbor, I can able to look up. Delete means how to delete a particular neighbor. Neighbor purge means similar like duplication of data into one common data. Next thing is broadcast ID management. So we have insert the broadcast ID, look up the broadcast ID, purging the broadcast ID. So many times the AODV protocol deals with the broadcast ID, because whenever it needs to form any local network, it will send a broadcast ID to all the nodes. So broadcast means whether the node is part of the network or not, everyone will receive the broadcast. That's what broadcast. Next thing is packet transmission routines. TX routine means transmission routines. You can see there's a forward packet, send hello, send request, send reply, and send error. So route request, now you can see that there's a RERR, RREQ, RREP. So this how we have seen that. So routing error, route request, and route response. So these are the three things available here. The three things any node can able to send. There's a transmission routines. So forward is forward means I'll take the packet, I will not see what is there inside, I will just send it to the next node. That's what forwarding will do. So the parameters are routing table entry, which node I need to forward, what I want to forward, and what delay I have. So how long I can able to store the packet with me. So these are the three entries available. Suppose for forwarding itself I want to include one more parameter, then you can include it here. Let's say trust. For example, people will use trust behavior of a node. So let me use integer trust. So that means during forwarding also I will go for a trust value. So when I forward a packet, if I want to use a trust value, so how can I use my trust value inside my network? So in that case I can use only on the forward function. So this kind of modification I can able to do. Anyway, I will just remove that. So this is how way I can able to do the modification. The next thing is send hello. So I can able to send the hello packets, send request packet. That means okay, send request. So you can see the destination here, address type is destination. Send reply. So in the destination IP destination, hop count, IP receiving destination, and receiving sequence number, then lifetime of the node, and the timestamp, and what timestamp it was sending the reply. So whenever I send a reply, I maintain all this information here. Then send error. Send error is packet B bool jitter equal to true. So because what due to what there was an error. And packet receiving routines, you can see receive AODV, receive hello, receive request, receive reply, and receive error. So for everything we have packets only, because receiving doesn't depends on anything, just we are receiving the packet, that's it. So only parameter is packet. Then history management. So in the history management we have per hop time. So what is by history? So I am sending the second packet. If a source node sending a second packet to the destination node, the first packet route will become a history. Or if it is go to the third hop, the first second hop will become a history. How do I store? Where do I store the history? So that's what here per hop history management. Then we have parameters, index, sequence number. So NS address type, index, and integer 32 bits sequence number, and routing table, routing head, and neighbor cache, and broadcast ID head. You can see everything is given. And timer, what are the timer initialization? I create a variable for b timer, h timer, n timer, like this. And routing table, I created a variable name r table, and routing queue rq, and trace log target, and priority queue if queue. So this we have seen in setting the wireless parameters in the lecture number 6 during wireless network design. And these are the logging stuff. So that's it. So this is what my aodv.header file, and this is my aodv.cc file. Oh, please remember, I am not going to explain the complete aodv.cc protocol. Anyway, then and there I will explain you how that things works. Okay, now you can see this class we have seen in the last lecture in creating a new agent, static class aodv class, public TCL class, agent class aodv. So this is what we have used it here. Okay, now in the command function, so the same command function we use in the earlier new agent also. Here you can see argument count equal to 2. If string case comparison id comma 2 equal to 0 and start equal to 0, and we will be attaching one more case statement here in our next part 2. So you can see there are so many things available in this algorithm. Almost the number of lines is 1391 lines. So we cannot able to learn everything at a given stretch. Okay, so now what I do here is I just go for adding a small counter. So now the action begins. How do I modify the AODV protocol as per my small piece of algorithm? Okay, so now what I am going to do is I would like to print the nodes that are forwarding the packets. So this is my algorithm in AODV. I would like to print the nodes that are forwarding the packets. So two information will be recorded in a text file separately. So first thing is the name of the file is use name of the file, output dot data file. I use like this aodv underscore output dot data. This is a file that will be recording data recorded will be forwarded packet comma node index. Index means node number. Okay, so this will be recorded here. How do I do that? How I am going to do this? Okay, so now for this, please open the aodv.head and the aodv.cc file. Okay, so I'll write the statements first. Anyway, I'm just writing on my own. So what I do is in the aodv.header file, add a variable called as pkt underscore count as an integer in protected scope. Inside the aodv.header file. So what I am going to do is I am going to add a variable called as int pack count. So I'll add this here. So I go to aodv.header file. So you just go here. Now in this agent class aodv public agent, so what I do is I will be adding a variable here. So what I do is I use added by Pradeep Kumar TS. Okay, so I use the following line added by Pradeep Kumar, int pkt underscore count, hope the same variable will not be there. So please use the variable which is, suppose if the variable is already used by NS2, you will be in trouble. Okay, so please use the variable name accordingly. Packet underscore count. Okay, so I'll be using this variable name. So I am initializing. So initializing or declare a variable. Declare a variable. I use integer, so that means please understand accordingly. Okay, now second time, this step 1. Step 2 will be initialize packet count with the value 0 in the aodv.cc file, preferably in the constructor. Please remember, so I am initialize a packet count with a value 0 on the aodv.cc file, preferably in the constructor. I am going to install in the constructor, so in the aodv.cc file. So you can go and check where is the constructor available. So if you could not find out, you can see that there is a value constructor. If you could not find out, just select Ctrl F and find constructor. Yeah, constructor is here. So you can see this is the constructor. So you would have seen this in the new agent creation in lecture number 10. So how I am creating a new agent and a constructor. So please remember that in this it is acting on a packet called as pt underscore aodv. You remember now, in the earlier lecture it was given as pt underscore udp. We have given in UDP like Pradeep agent. I have designed an agent. Now you can see B timer, broadcast timer, routing timer, H timer, LR timer, local repair timer, and N timer, RQ. They are all initialized. Now these are the variables. Now here what I do is, I use again the following line is added by Pradeep. So what I do is packet count equal to 0. Since packet count I have designed as integer, so I want to give it as 0. Okay, so now my second point is done. So first thing is I use this integer packet count, then here I use packet count equal to 0 semicolon. Next thing is step 3. Step 3, since I am going to get the packet counts in a file, I need to create a file pointer. But first let me get the data in the terminal itself. Later I will create it in the file. Okay, so I am going to create also only during the forwarding of packets I am going to get the count. So my code will be running inside the forward function. Okay, right, so this is a forward function. So let me go to the code now. So what I do is, forward function will be having some parameters. So again we will, when you find it, forward, F-O-R-W-A-R-D, forward. So we have to find out the function definition. Use a curly brace like this. I mean use a round brackets here and check it where this forward function. Yes, here is a packet transmission routines. We have a forward function. So it has so many parameters. Now in this here, always don't write inside the if statement or anywhere. Just inside the forward function you do that, but don't write it inside a loop or anything or any if statement. So now here I will be writing. What I will be doing is just I want to printf. So I want to define two parameters. One is the number of packets forwarded and the node number, which node is forwarding. I am packet number %d, because packet number I want to use %d, and from node number %d, node number also defined in %d, use a /n. close this. Now for this percentage d, my variable name is packet underscore count. Now please remember, packet count is already initialized to 0. So every time when the packet is forwarded, you will always get the value of 0 only. So but every time when the packet is been sent, the count has to get added. So I use packet count plus plus. Hope you have got understand. Packet count plus plus comma. In NS2, anywhere you write printf percentage d index, that will print the node index. So it is a defined variable in within NS2. I can create the index and semicolon. Okay, so what I have done here is this line I have included here. Again, I will be writing it here. The following line is added by Pradeep. Sorry, yeah. So now I have added the following line. So now this line I have added here. So add the following line to the forward function of aodv.cc. That's added. Okay, done. Next step 4. Step 4. Now recompile NS2 using the command make. So how you do? So go to cd ns hyphen all-in-one hyphen 2.35 slash ns hyphen 2.35, then $make. Okay, so now what I do here is I just create a terminal. So cd ns all-in-one 2.35 cd ns 2.35, and here I will be using the command. Yes, so now I need to use the command make. So once you try make, AODV is compiled. I don't know whether it is compiled successfully or not, but I didn't get any errors. That indicates that the compilation is successful. But what I do now is I'll just make an error so that it will throw an error. Let me remove the semicolon here. So it will be it should show an error. So when you see that, it shows an error. So before if there is a semicolon is expected in line number 1010. So here is 1008. So before this the line is expected. So I use a semicolon. So that means my code is compiled. Right. So now my code is compiled. Now I need to test. Please remember, NS2 is all about the C++ will be running in the backend. So now I have modified something in the backend. Now it should run. Front end will be by the TCL files. So already I have created a TCL file which is there in my home folder in performance analysis of wireless ad hoc routing protocols. In this topic, in lecture number 9, I have created it. So aodv.tcl file. So this is the aodv.tcl. You can see I have the routing protocol aodv. So number of nodes is totally 17. So I have this is the source code. So you can download the source code from my website nsnam.com. Okay, so let me use. Once there are no errors, your code is compiled successfully. Okay, so it's compiled successfully. Then run any wireless TCL script that has the routing protocol as aodv. I am running aodv.tcl file that was generated in lecture number 9. So refer lecture number 9, performance analysis of ad hoc routing protocols. So this I am going to run it now. Okay, so to run that, just ns aodv.tcl, then it will, or else nam, I can run nam aodv.nam. So anything you can run it. Okay, so now I will just go to this home folder ns aodv.tcl. now see that when I run it, okay, you got it, you got the output. So actually this is what it happens. So this is how the network works. There are totally 17 nodes, and this is how the packet got exchanged, and the forwarding packets, how the packets have been forwarded. We do not know through GUI, the animation we do not know, but through the output file we know. So what happens here is, so these nodes are forwarding the packets. Okay, so you can see how many packets the node is forwarding. So such a long data. So what I do in now is NS AODV, I can use this command ampersand greater than, that is to redirect the file, and name of the file is output, simply I will put output, it's there in the output now. Okay, so gedit output. So you can see this how it happens. So there are totally number of nodes is set to 17, and I am packet number 0. Initially it's packet number 0 by all the nodes, and packet number 1, 2 like that. So I can have, so these many, the node number 5 have forwarded totally 445 packets. Node number 15 forwarded for 445 packets. Then node number 12 forwarded just 222 packets. You see the last value what it was, and the 12 also the last number. And node number 11 forwarded 449 packets. And any other node other than these numbers. And node number 3 forwarded 222 packets. And any other node. So I can able to get some information from this packet forwarding routines. So this I just created a file. Now my code here is, I need to get this output in a file called as, so I already told you that I need to get a file output called as I want to create a file as output dot aodv underscore output dot dat file. So I want to create a file like this. So in this file only I am going to create it. So now what can I do is, how to do that? Again the same step, open aodv.cc and aodv.h. okay, so the same step I have done in the beginning itself, but I will be telling you how this can be done. So now what I do is, I use file star fp. So I create a file pointer. Okay, please remember I create a file pointer and declare a file pointer, and let me use it here. Declare a file pointer inside the aodv.header file like this, file star fp. Okay, then initialize this file pointer in aodv.cc constructor file, in the constructor. Okay, so how can I do is, fp equal to fopen, this is a command, fopen, file name is aodv output.dat, it's under w mode, that is write mode. Please remember write mode is not a character, it's a string here, because sometimes we'll use write w plus or wa or a plus, will be using that. So it is a string, so you should use a double quote here. So this code I will be using in aodv.cc file. The aodv.cc file constructor I will be using this line. Okay, so fopen, this is a C syntax for opening a file. Okay, so then what I do is, I'll just go to the forward function as I did. Okay, this is a forward function. So here I use printf here. Now simply I'll change fprintf, then the file pointer name is fp comma, that's it. So that means fprintf means file printf, write it to the file pointer fp, which is pointed by aodv underscore output.dat file, and use this statement. Okay, so done. The same coding, it's done. Now what I do, I did a modification, I need to recompile it again. So what I do is, I'll just go there and I'll just type the make command. Once I type the make command, my code got compiled. Okay, now what I do, the same code I will be running it again, aodv.tcl. Now you can see nothing is getting printed here. Hope you understand. Now nothing got printed. But what should I do? I should check the file for availability. can check the file here. aodv, you can see there's a file called as aodv underscore output.dat is created. Just open. Yeah, you got it now. So here's a file it got created inside this aodv.header file. So node number 11 sends 450 packets, node number 5 sends 445 packets, and node number 12 sends 222 packets, and node number 3 sends 222 packets. And what are the forwarding nodes? We have only 5. Node number 0, node 2, 12. There are some less number of forwarding nodes. So that's it. I got it. I got the output. So this line, the final line is fprintf and use fp comma. Include the following line in the forward function aodv.cc, and we got the output. And run the aodv.tcl file and check for a file called aodv underscore output.dat is created in the same folder where the aodv.tcl is residing. Thank you for watching. To download this code, to download the codes, visit name.com and share and subscribe to this video to my YouTube channel, youtube.com/tspradeepkumar. Stay tuned for more lectures.